relationships that go through, and I give it all away just so I could say that. But I know that you're gonna be okay anyway.
Good morning, ladies and gentlemen. My name is Greg Goodner. I'm president of MHI, and obviously MHI is sponsoring ProMat 2017. So for those of you that were here yesterday, I hope you have been partaking in a lot of the events that ProMat has to offer, from the educational sessions, the keynote speakers, to the theaters, to obviously all the activity that's going on down on the floor. For those of you, if it's your first day, let me tell you, there's a lot happening out there. And I think you're going to enjoy what you see and the interaction. And please take advantage of a lot of the educational sessions we have in the theaters and the different areas around the expo. I think you're really going to find a lot of things that you could take back home and hopefully apply in your businesses to help increase productivity and efficiency in your operations, obviously, as we march forward. This is the largest ProMat that we've had. It is the largest manufacturing and supply chain expo in North and South America. We have over 950 exhibitors with ProMat, and then with the group that we've co-located with, Automate, we're talking about 1,350 exhibitors. So please get on all sides of the show and look at the activity that's going on. I think you'll really be amazed. We've got a great event this morning on our keynote speaker. We're going to talk about a topic that's going to be affecting all of us if it's not already starting to affect us. Industry 4.0. How intelligent machines are transforming the supply chain. Markus Lorenz, who is with the Boston Consulting Group, is going to explore the ways that this revolution is impacting not only our industry, but our global economy. He's also going to talk to you about how this Industry 4.0 is going to create new job opportunities as we march forward. Markus joined the Boston Consulting Group in 2002, and currently he is a partner located in their Munich operation. He leads their machinery and component sector worldwide. He works with a lot of leading automation firms in helping to explore the opportunities that are going to be provided by Industry 4.0 and the Internet of Things. Markus is a well-known authority on the topic of Industry 4.0. He has authored a number of publications on this topic, and it's about how the technology is going to be transforming the industrial workforce all the way through 2025. Markus studied industrial engineering at the University of Karlsruhe. He holds an MBA from Vanderbilt University and a PhD from the Technical University in Munich. So please, without further ado, let's give a warm welcome to Markus Lorenz. All right, buddy, it's all yours, man.
Greg, thank you so much for the kind introduction. Good morning, everyone. This is really amazing. It's 8:45 and the room is packed. If you were expecting to see Hans in France, I think that's going to be tomorrow night. So bear with me a little bit of other Hans in France stories that have a little bit more to do with technology. That's basically technology and business. That's what I do when I'm not doing sports. And this is my first link to that. You know, we're using those modern technologies in our daily lives, right? When you're cycling, you're using that. The guys in Japan don't seem to use their own kitchen anymore so often, have a lot of robots on that. The question is, will that at some time also hit our factories? And I do believe that, the perception how manufacturing, work in factories and supply chains does work will change a little bit. Maybe a little bit to the right side, but I think there's more to that. And we often call that basically Industry 4.0. So I think most of you are familiar with the term. We're using it a lot. I don't know whether everyone has the history of that. I think it's a coined brand nowadays, where it's coming from. We're basically saying it's the fourth time that basically industry has reinvented itself. First was basically, when the loom hit the production, so to say, and took horses and human labor out. Second, basically, is associated to linear assembly systems. People always refer to Henry Ford's Model T, which you could mass produce at low cost. When you really, really look down and deep down, you find that this principle was first applied here in Chicago, in the slaughterhouses of Chicago. They basically had the principle of line assembly and separation of work in stations way before Henry Ford had implemented that for his Model T. Well, the Model T is still a much better marketing example, so we refer to that one. Third industrial revolution, and this is basically, I think, the paradigm of how we believe a factory looks like. Fixed line automation, robots, assembly systems, all the good stuff that you guys are also doing business and making your money with. That's there and it's established. And I think the fourth revolution is now the interesting thing when we combine all the good stuff and all the brilliant stuff we have from automation and combine it with a new intelligence that's coming from technology, from connected systems, from Internet of Technology, for example. So there's a whole range of technologies behind that. Some of them you're aware. You are exhibiting that these days, or you're using that in your factories, whether it's basically additive technologies, building up a part, whether it's a polymer, or whether it's now also in titanium or steel, or using augmented reality in service jobs or in assembly jobs. So that's more or less basically there. It's not yet full-blown, and it's also not yet connected. And I want to basically take you through a little journey where I believe what's going to happen if we use that all and we connect it all. But let me begin the story basically in a world which is not connected, and it's again a very personal world. This is a yogurt, 500 milliliter a glass, so about 12 ounces. That's what I had. As a teenager, I grew up in the Black Forest, southern Germany, healthy outdoors, spent a lot of time outdoors. So on top of the meals that were provided in our home, and I believe they were healthy and good meals, I had one of those yogurts to supplement basically the intake. On a very, very good day, I could have all 4 of them. They came in those 4 flavors, raspberry, vanilla, strawberry. Today, a couple of years later, the same company still exists. It changed the ownership. The brand still exists. The only thing is the product now comes in 96 variants. Those include some very fancy ones like hibiscus, aloe vera, cinnamon winter apple. So obviously tastes that cater to a very, very special crowd or to seasonal events. Another fun fact is basically in Europe, the consumption of yogurt is flat. Now, people are not consuming more yogurt than they have been consuming 20 years ago. Now, Greek yogurt is a different thing. That's a new category. But when you look at yogurt and such, consumption is flat. So what that basically means, it's a big, big campground, so to say, for marketeers who are basically doing everything to shuffle around customers, basically bringing new flavors to customers, but in the end, they are not growing the category. And for guys in production and supply chain, it's a little bit more complex because what happens there is basically that complexity explodes because you don't only have the 96 variants, you want to have also the packaging behind that and the flavors behind that. So there's a lot of possibilities to get something wrong, and why something gets wrong, I will tell you, and you will see that basically because the place where those yogurts are today produced is this one. This is the largest yogurt factory in Europe, so the one that still produces those yogurts that you've seen. And if you look at the picture, I would say it pretty much looks like a mess, right? And it is a mess, and that's the result of basically this company growing, adding complexity, adding new flavors, adding new products, and not growing the factory essentially, but putting more stuff in there. You don't see many people, at least on the very shop floor. You see people in the so-called magazine, supply chain logistics jobs, where they're in-feeding stuff. And basically the way how you operate such a plant and control such a plant, well, it does not only look like a control from a nuclear power plant, it actually is a control from a nuclear power plant. When the guys had basically set up that system, and it's something between process automation and discrete automation, because you have all the mixing and processing, and then at some point of time this becomes a discrete product. They basically looked, where do we find that? And indeed, in the 70s and 80s, most of the control technologies came from nuclear power reactors. So they implemented that. That's how the guy here on the left is operating that. The guy here on the right is the head of the production, and what he's doing there is basically he's checking whether everything that he wants to be done in his factory is really happening, so he walks over the valves. That's something that you don't want to see too often in the food and beverage plant, right? Because that also is a risk of contamination and the likes. But with basically the whole complexity and the whole mess, and still we have great machinery, as you've seen here, a couple of problems do appear. You know, this machinery is very reliable, very robust. Also it fulfills basically all the requirements that you would have with regards to FDA, hygiene, and so on. But in essence, the machine is not intelligent. So what happens quite a bit is, for example, the machine, let's say we load it with a hazelnut yogurt, and it's basically able to fill some 24,000 of those jars that I showed you in the very beginning with that machine. Very efficient. No problem in that. The only problem is that at some point of time, maybe a person feeds in the packaging, and let's say he feeds in chocolate packaging. Yeah? So the machine will do exactly that, filling hazelnut yogurt in a chocolate packaging, or 24,000 of them per hour. Now, in our nuclear power plant-like control system, we have two ways to basically find that out. In end control and inspection, we might find out that basically there is a misfilling, a product loss, we call that, because there's no way back for that product into the food and beverage life cycle. Maybe you can bring it back into pig farming, but there's no way to bring that product back into the human food and beverage life cycle. Well, that's a good case, right? Imagine our control system doesn't detect that error. The product leaves the factory, and we see basically a guy who wants to consume chocolate yogurt because that's what's on the label, and in reality he's consuming hazelnut. Well, at some point of time this might be an issue of taste, but imagine this guy has an allergy against nuts, you know, he might have a not so pleasant afternoon. So these are the types of errors that exist, because I believe machines are doing great things. You know, when you compare it to the human body, they are great actuators. You're moving stuff, and you're moving that really fast and reliable, and much better than any human being could do that. But they're not using and doing what humans are doing, seeing and sensing. It's basically what you guys are doing when you're working with sensors, and they are not processing, because processing would be, I sense that I'm basically right now filling a hazelnut yogurt. I'm sensing that my packaging is chocolate, there's a mismatch, I'd rather stop that process or check with basically my control system. And that's that very intelligence. You know, when we talk about IoT and Industry 4.0 making machines intelligent, you can relate it to such a simple example. And basically in the world, that so-called product loss in food, that amounts to something like $18 billion a year. So good products that are just thrown away because a good product in a good packaging, but just not the right packaging. And that's an obvious, as you could say, waste. Japanese guys would call it muda, and also obviously a value opportunity when you apply those technology. So that's one thing, basically, what Industry 4.0 on a machine base is able to. I'm also thrilled, by the way, how this relates to a whole value flow within a plant, because if you look at a lot of plants today, then you would basically see this paradigm. Yeah, plants today are often set up by what I call cells, and whether this is an example of a packaged good, or you can also think about a car. You have a stamp shop, an assembly shop, an assembly station or a final station, and typically what we've done over the past is we've been optimizing those cells. And we took out time, we took out material consumption, we took out waiting time or errors. But what we've done also is in between, and this is indicated by the little green and yellow boxes, we created waiting times, we created inventory, we created those type of interface problems that I just mentioned with the yogurt example. And this is, when you really, really look deep, and I think you find a lot of highly automated factories in the US, but also in Western Europe, and also in Japan. But when you're really critical about that, and in the end, the most automated factories are in essence an array of automated cells. And this is indeed an opportunity for Industry 4.0 to change that, because we can equip basically machines with the type of sensing, the type of intelligence I just mentioned. We can make machines communicate to each other, to the people. We take out the inventory, and we also enable basically a continuous flow of information throughout the supply chain, from customer to producer down to supplier. Let's look at those technologies a little bit deeper and mention a couple of them, because this is basically when you look at a little supply chain from a factory to its suppliers, what can be done. And I'm sure you guys are exhibiting a lot of that today, whether it's supply chain towers that can control where goods are flowing, whether we're talking about decentral production, you know, with modern technology, 3D printing and the likes. It's not necessarily the case that the biggest production hub in the world is the most efficient one. A couple of paradigms are breaking there. It's also the case that basically it's not that time doesn't matter. A very nice example is, from my point of view, the fashion industry or garment industry, you know, which for decades was on the hunt for the cheapest labor around the planet. Basically, China, Myanmar, Burma were competing over who could produce a T-shirt for $2 rather than $3. Now, a couple of those paradigms change because people are relating to something what we call fast fashion. And fast fashion, the idea is basically what you see on a Saturday night show, Sunday night show, America's Got Talent, or whatever you have on the shelf on Monday or Tuesday. And you cannot obviously realize that if you have a supply chain that's made up of producing the stuff somewhere in Burma, Myanmar, and then shipping it over the ocean for like 3 to 4 weeks. That's just not doable. But you have like a place where you do digital printing of fabrics, where you have smart knitting, for example, of fabrics. Then this is possible to do. And very often those places are in Mexico or are in Turkey and Portugal for Europe. So this changes the paradigm of the industry. Now you could debate over whether producing stuff for basically schoolyards is a good business model, but there is a business model out there, right? And kids love it, and whether it's good stuff that lasts for more than 6 weeks doesn't matter either, because in 6 weeks' time there will be a new fashion trend that those guys can pick up. So I think that's a little bit the notion of a supply chain. And when we look deeper into such a plant, I think again a paradigm changes, and we saw that earlier. In the past, the paradigm has often been a fixed line, and let's optimize that fixed line, and let's push so much through a fixed line as possible. And I think in the factory of the future, that will look a little bit different. First of all, the factory of the future starts with what we call a digital twin. You know, this is created in the lower left of that picture, where basically an order is translated into a digital twin. The digital twin basically decides what's the best way to produce that. Our machines are basically communicating with each other and are communicating with the parts. So parts know what should be done to them. Machines know what also the next step for them is. We have people on the upper right-hand side working with the help of augmented reality glasses, working alongside robots. I'm sure that's a big trend. When I ran through this morning here, you see how you can uncage robots. You know, robots were almost a dangerous thing, close to Terminators a couple of years ago. Now I think the industry is making great progress progress of uncaging the robot, making that robot work alongside with humans, or some applications, some use cases taking over jobs that's not so easy for humans to do. You know, I work with a producer of smart implements, grippers for robots, and they've been working for a long time in food and beverage, for example. How do I teach a robot to grip an orange without basically making orange juice out of that orange? Well, that's possible now, and I'm sure a couple of you guys are working on that. Technologies in sensing and pneumatics make that possible. Next generation basically is, okay, let us just pick those oranges that are good oranges and put them into the box. Well, that's easy done. You just take a camera that's a little bit better than the camera that's in your iPhone, and the robot becomes sort of semi-smart because it's now seeing, and it only puts the oranges into one box, and the other ones he throws away, or he really produces orange juice out of that. Now, next level is basically, let's not only use the image recognition, the machine vision from that robot, but let's also use what we call detection of volatile organic components. That's what basically happens when inside of the orange starts to rotten a little bit and starts to emit those components. That's a clear indication that there's something gonna be wrong with that particular fruit in a couple of days. So the robot is basically able to sort of predictively put those oranges into one box that will make a nice appearance in the supermarket also in 1 week from now, and the other ones not. So that's an element where we believe, you have upsmarted a very good piece of equipment, and it's adding more value than it's used to do in the past. And these are those type of applications that we are looking for. Also, when you basically see that we have automated forklifts, I think you see that around the show here also a lot. But to me, it's very important that products do not end their life when they are out of the factory. A couple of very precious products, whether you're talking about food and beverage, or you also find that, for example, in industrial chemicals, you want to make sure that throughout their life, once they have left the factory, you can control what happens to them. Are they exposed to the right temperature, to the right pressure? Has someone opened them who shouldn't have opened the products? And those are all technologies that are now becoming, I wouldn't say cheap, but they're becoming affordable. You can attach sensors to those products, and those sensors can be easy RFID sensors, but you can also move to 5G, so you make it connect anywhere, anytime. The energy consumption of that isn't also that high anymore, and you can basically see what happens to your product after you've left the factory. A technology provider I work with very simple technology in RFID, for example, we decided to just let an RFID chip fall into a bacon mass of plastic that comes out of an extrusion process. The components go into automotive cockpits. So basically that means within a plant, the cockpit and the instruments find together rather than a person looking up at some kind of paper that's attached to the product. So you find that matching itself, and we thought there was a great use case, but the real use case kicked in when we looked at the aftermarket, and finding problems in automotive cockpits and tracing them back to the date of production, to the factory, to the machine even, and that led basically to a massive improvement in the molds of the extrusion machine. So this is basically you are able to collect information from the field, trace it back to the point of origins, and those are, from our point of view, from my point of view, models that are very interesting for producers. So talking about producers who can basically reap all the benefits from the technology, I don't say they have to do everything at a given time, but let's look also at equipment providers in a second, because I also think that they can benefit largely from that. And you guys are ultimately, I guess at least half of you must be equipment providers showcasing your technology here. So I think there are also interesting times ahead for you. Let's look again at an example. This is a company I work with. It's basically installed in a lot of the harbor cranes of this world, and you see this here, heavy type of equipment. And this company is basically providing the motors and the drive, partially also the gearbox, that's controlling and doing the actuation of the containers that go on such a vessel. And this is a very small vessel, you know, of the big Cape-sized vessels that are around, which are increasing in size every year. So this is a pretty heavy job, and the equipment is also very nice equipment. So you can basically command a nice price for that. Say you're selling the motor and the drive for something like $5,000. Well, that's a good business model. You can do some after-sales business out of that. Very nice. Well, when working basically with a little bit the sensors, Internet of Technology and Industry 4.0, we basically found out, why don't we do the following? Basically, the drive that's controlling the motor can sense, obviously by moment of inertia, what the weight of that container is. You can even tell what the internal weight balance on the container is. And as you know where you basically place the container on the ship, you have what we call here a digital model of the ship with its weight balance. And obviously, that's rather intuitive. A balanced, a well-trimmed ship is better than a not trimmed ship. Anyone of you who does open water swimming knows that. Swimming like that in the water, that's what most people do, included myself, is not so good. Swimming like that is much better. For an ocean vessel, swimming like this as opposed to that, or left and right trim, means something like saved fuel of something like $5,000 a day. Just by optimal trimming, not changing anything, just the better allocation of containers on a ship, and thereby enabling a natural trim of the ship enables that fuel saving, because in essence, the ship doesn't have to work against the trim or correct the left and right balance. So we figured, why don't we use that intelligence and basically sell it? And why don't we change the business model to something like this? So rather than selling our beautiful piece of equipment, the motor and the drive, for something like $5,000, let's sell each and every weighing and placing movement for a couple of cents in this case. Well, if you do that well enough, or basically enough times over a year, in this case 100,000 times, that's not a heavy payload for a harbor crane, you can result in something like 10,000 euros. So that's only per year, as opposed to the 5,000 euros or dollars that you would basically take over the lifetime. So obviously a much nicer, more stable, and also more profitable business model if you are able to basically reap the benefits from technology. I must be fair and say there's a little bit of legislation that helps there. There's a legislation coming in that basically says we want the weight of a container to be measured at the moment before the container is going on a vessel. And it has to do with that the weights that are in the paperwork are not always the proper weights. They might be optimized for other purposes than technology, maybe tax purposes and so on. So this helps us obviously, and harbors have to think about how to fulfill that new requirement anyways. And if a company kicks in that says, well, I'm going to help you, dear harbor, to fulfill your duty, and I'm going to help you, dear ocean vessel operator, to optimize and reduce your fuel cost. That's obviously a business model, and there's also obviously some money left over for those guys providing the intelligence behind that. So with that, I sometimes get the question, well, Markus, understood. It's nice for producers what you're saying. We can produce smarter. We are taking away those problems with, for example, the misfilling of a yogurt. It's obviously also good for equipment providers who are embracing of that technology and who are translating the technology into a business model, such as the motors and drives company did. But I'm also getting the question, what about us? What about human labor? And Greg mentioned at the beginning. Is it just that we are sitting there and watching as the smart machines and the self-controlled supply chains are taking over our job? And the very simple answer to that question is yes. There is an element where basically there is no need for humans anymore in their process, or we don't want to have them in the process anymore, like the head of the food and beverage production we saw earlier walking over the pumps and valves in his yogurt plant. We didn't want to see that. So there is an element where this is happening, but this is not the full story. The full story basically has to do with also the type of works that are changing. So indeed, and you guys, a lot of you guys are working on those autonomous hauling systems within a plant. I think we're going to see that as a de facto new industry standard. So if you basically define your fortune today of driving a forklift truck, I think the end of that business model, so to say, is near. We will see people working alongside robots, because the robots are uncaged and helping, for example, here in consignment jobs. We will see fully automated production. We often see that, for example, in clean rooms where we don't want to have people running around. This one is a favorite example on the upper right-hand corner from Siemens. The true story is also that a lot of people are involved in that you don't see in that picture. We basically see predictive abilities, so machines that can basically tell when they need service, and you also see when we come to service, you see people being supported by, for example, augmented reality glasses that will help them fulfill service jobs, maybe even service jobs that they were not so well prepared for in the past, but technology basically helps to fulfill them. You see them on the upper right, on the lower right corner, sorry for that. So I'm working with one company. This is, again, for me, a very nice illustrative use case when you're talking about wind turbines. Wind turbines are somewhere often onshore or more often now offshore. They are subject to service a lot because they are faced with the forces of nature. And their real problem is basically finding people who do service on those wind turbines, because the interface of people who like both climbing up such a turbine 150 meters and at the same time being engineers and technicians well enough to repair such a thing, the interface of that of those two groups is fairly small. And when you look at that interface, the sort of effectiveness and productivity of those people is ridiculously low. Those people typically spend something like 30 to 40 minutes of their day being productive on a turbine, because their job is basically going there, securing the site, climbing up there, checking something, climbing down, phoning the guy in their headquarters, checking what's wrong there, and then if they are good, climbing up again and fixing it, but most probably doing that the next day. So with a very, very scarce capacity, we are not dealing well. Now, if you equip those guys with an augmented reality glass, you can basically experience the head office engineer what the guy on the wind turbine is seeing and help him while he's doing the job. Unlock the gearbox or check the generator. That's something that probably is difficult for a guy who's doing that only a couple of times, but if you talk to the guy who's designed the system, that's an easier job. Now you see stuff that basically you are providing here. That's reality now in most automotive production lines, for example, that people are working alongside with robots. The robot is taking over the not so nice job of basically fixing this door here. The worker prepares it and controls it. Or basically, we mentioned that one, automated warehouse solutions. I think there are some very, very nice examples here around the ProMat where you can see those things alive. And I do believe this will be for sure the new future when it comes to warehousing. Now on the overall picture, because we mentioned at the beginning, are we just sitting there watching as the smart machines are taking over our jobs? And we took a deeper look at that and modeled that a little bit. And you basically see here all type of jobs that you could think of, starting from the right in production, quality, administration, sales, service. And you see on this axis the industries. And the valley that will now appear basically indicates what kind of jobs will be lost over the next decade and what kind of jobs will be gained over the next decade. And this picture is quite stable over countries like the US, over Japan and also Germany. The figures I have in mind for Germany is basically this economy, and there is some 10 million people employed within the factories. We're not talking about the service economy, but within the factories, and we will lose something like 600,000 of those jobs due to the smart machines taking over the controls. So that's basically the valley you see to the right with the red valleys on production. But the very interesting thing is also we will gain new jobs. We will gain jobs in sales and service. We will gain jobs in field service activities like fixing the windmill example I just mentioned. We will also gain jobs in designing the business models. Think about our motors and drives company that's now basically selling picking and weighing and placing mechanisms rather than selling equipment. You obviously need data analysts and business model designers all around that. And obviously you will need people that deal with all the data and all the systems around that. So the gain in job is something like 1 million. So that's a net gain if you subtract the loss out of that of 400,000. So in total, this will be a winning game for the economies. In some places you already see that. Japan, Germany, also parts of the US where basically we cannot find enough people to do the jobs in the factories and also in the services, but I think this will continue. Of course, this is not exactly the same job profile, and you cannot just take a guy who was operating on a machine and make him a data scientist. I know this is not realistic, and the numbers in that essence look nicer than they fundamentally are, but there is a link in between, right? You can very well educate and upgrade someone with the help of technology, for example, augmented reality glasses, and let him do jobs that are highly value-adding, for example, in field service operations, right? Anyone who has a basic understanding of operating a machine and a system can do that within a factory or maybe at a higher use of his time outside of a factory, and this is basically what technology helps us do so. So this is why I'm personally, when I take it that big opportunity for producers, nice opportunities for equipment providers, guys like you, but also good news for the labor market in general. And with that, basically, let me conclude. So when I work in this so-called Industry 4.0 world, what is basically my conclusion and what do I see? So first on this topic of complexity. We saw it in the beginning with the mess that was created in that yogurt factory by the rise from the 4 flavors of my youth to the 96 flavors that are now in presence. Well, as an engineer, you might say, let's cut that complexity and let's get rid of cinnamon winter apple. Well, in reality, there's no way back. Once complexity is there, your only option is basically to work with it, not fight it, but basically find a doable way to work with it. Technology helps you, because for a machine that has vision, that is sensing, it doesn't matter what kind of properties you have, it will just help you master the complexity. Second is basically, second is the type of fiction and reality. Yes, a lot of the things, maybe the continuous flow I mentioned today where the digital twin of the product is there, tells you automatically where it's going and it's implemented in the field and it traces that information back. That's a little bit fiction, I do agree, but there's also parts of that are reality and informations are being used. And for example, when I talk about that harbor crane operator, the information what's in of the moment of inertia is already there. Anyone who picks up something can sense the moment of inertia, can trace that back to the weight and the balance. So it's often that you don't use that right now, you don't connect it. So I think it's important to think towards the fiction, what if that all becomes connected and real, but also start working on that in reality. And third one, maybe the most important one, is the human factor. It's not that basically those smart machines are just taking over and it's going to look like the planet after Terminator, but I do believe that human labor will play a critical role both on the shop floor, in the field force, and in design, and in engineering, and of course also in selling. I guess a lot of the business in the next couple of days will also be around that, so it will stay. Just the nature of that will be a little bit different. And I talked to the boss of the international labor associations of the world, and she's a very nice lady from Australia, says, okay, I have 400 million workers behind me. I found that pretty impressive, but those are also people that are actively thinking of how do we help our workforce to translate to the new future. With that, I basically wanted to conclude or open it to the Q&A session. As you see, I'm thrilled by the opportunities that are out there for us, for technology, for products, for producers. It's not all that easy. There will be more work to do. But I think you being here are part of the journey, and you're all basically contributing enormously to what's going to happen in the next couple of years. So with that, let me thank you for a moment and then hand it over to you guys. Do we have questions? We have a little bit of time for questions, so
I have a question.
If you like.
Is the mic on? Oh, yeah, thank you. Dr. Lorenz, hi, my name is Karen Leavitt. I'm with Locus Robotics. And you speak about the different generations of robots. You had the robots that are protected from humans by safety barriers. You had the AGVs that move along a defined path. You have the sort of static collaborative robots. How do you see the breakthrough of the true autonomous mobile robots that move in concert with people and work collaboratively with human workers?
Mm-hmm. I think we are only at the very beginning of that. And if you talk, for example, to the guys at MIT, then they're talking about swarm robots. Yeah, how could little robots basically moving in swarms and taking over swarm intelligence fulfill the job of, for example, that one big robot is taking over today? So I do believe there's a lot of stuff happening right now with, as you mentioned it, uncaging the robot, making it safe to work alongside with that. But I think if you're critical, we have not put real intelligence into the robot, you know. And I think my favorite example of the orange, the robot doesn't crush the orange anymore, but he knows what it's doing. Yes, we added intelligence to the robot and to the implement especially. But did we really add intelligence to the system around that? I think you find that more in systems where robots know, for example, what kind of production line is producing what output, where does that output need to go next. If you really connect robots, I believe, to a higher level of automation know-how and process know-how, I think then this becomes really interesting. Or if you basically move to the stuff of so-called swarm robots, where robots communicate amongst each other. But I do believe we have only gone 5% of the way or so that's up there when it comes to really intelligent robots. But a fascinating field, and also what I saw this morning, fascinating providers here that showcase new technology. I will. There's one more question, yeah.
Hi. Thank you for your talk this morning. It was very informative. Just wondering, as technology becomes available to make robots faster and safer at the same time, do you see the ISO rules, regulations changing quickly?
I think they will have to change. I think ISO rules, I'm not a regulator or so, but I think ISO rules, if you read them, are still written under the paradigm that how can I avoid a casualty in a plant, right? And avoid that at utmost cost. And with new, that's a little bit like autonomous driving, you know? Autonomous driving is already that good that it will drive better than 90% of the people. Plus, an autonomous driving system will never consume alcohol or any other kind of stuff that you shouldn't consume while being on a car. The same, I think, applies to robots. And we have effectively brought second and third layer of security systems, for example, in an aircraft, right? Hydraulic systems in an aircraft are 2 times or 3 times duplicated for security purposes. I don't see why we couldn't do the same thing for robots and the technology to basically make a robot safe. You can do it with touch, you can do it with sensing, you can do it with surrounding recognition, and so why not use redundancy of those technologies, because the technologies aren't that expensive anymore. So I do believe that the technology will change, the use case will change, and also, again, I'm not deep into regulations, but the only thing that I can see from that is regulation will change, and regulation will see that basically this is not the threatening robot that will kill our workers anymore, but it's a guy, a piece of machine that will help do the work.
Thank you.
Thank you. There was one next, yeah.
Yes, good morning. Thank you for the great presentation. Are there any examples of industry and education institutions working together to prepare the workforce for that augmented reality engagement for the future?
You mean that's a very special use case or a very direct use case out of this example here, right? Basically translating or making people work along the job on the lower right-hand side. Yes, there are institutions around that without going into too much of advertising, but something I believe what the Fraunhofer Institutes are doing is really, really good because they enable an industrial test bed, where people can work with that. And to be honest, I said it in light words that basically on a wind turbine, that's a great use case for augmented reality. Yes, it is. But then in reality, it's also the case that data connectivity is not so good there, right? So we don't have the 3G, 4G, 5G networks that we would need to have a perfect video connection to do that. Still, we can do it with pictures, and exchange some 5 to 10 pictures per minute also tells a little bit about what's going on. And in the eyes of the head office engineer, there's also a little bit of a film then evolving from which he can tell what needs to be done. So, but I'm fully with you. There is also lots of work to do around that, not only with technology, how humans work with the technology. I personally can wear such a glass for 30 minutes, but after that, it feels a little dizzy. That's maybe not something I personally would be equipped for doing the whole work day, but those will be topics that will be worked on, plus the whole connectivity thing, the data bandwidth. Again, also here I believe maybe we've gone a little bit more of the steps. We're not at the 5% where we are in robots, I believe. We increased massively. Also, if you see what the big warehouse logistics guys, if you look at FedEx or DHL, how they've already implemented that very, very heavily in their factories, then I think this is already a true part of reality. But again, organizations working on that, partnering with industry, and what I always see, you can have the best professors in the world thinking about that, but they haven't thought about the issue that, well, on the wind turbine that's offshore, we don't have data connectivity, or in elevators, for example, also a very nice use case for service jobs. People are often working in the basement. Again, not a good data connectivity. So those are sort of the small things that you also have to consider when working on your use case, and that's why I believe bringing academia and industry together, there's also this Make America manufacturing network that's working on that. I think those are exactly the test beds that you need.
Thank you.
There's one question over there.
Markus, thank you so much for taking the time. I think my question is about adoption rates. So, as wonderful as all of this is and as large as this room is, the reality is there are still many firms that sort of question it and choose not to adopt. I think my question is to you, what would you say to someone who still has their skepticism, or maybe more broadly, what is US adoption rate like vis-a-vis, I know you have a deep background in Russia as well, or European markets or Chinese markets, just kind of where do we stand in the global framework?
You mean adoption of those new technologies and making them a standard?
Yes.
I think it happens quicker than one would think from the outside. For example, when you see that I showed those lightweight robots that only cost something like $20,000 for a robot arm. If you then see, or I mentioned the machine vision system, if you then see basically that one of the first industrial users of that technologies were premium automotive OEMs. Some coming from the area where I come from, Munich, then it's surprising how fast their adoption works. Those guys, to be fair, yes, they produce nice cars, but also they have a very, very heavy power into their supply chain upstream, as you know. If you want to supply into that industry, take EDI, electronic data interchange, you either follow that pattern of electronic data interchange or you're out of the supply chain. And I think a very similar thing will happen, for example, with the machine vision systems. If they are not relying on somebody checks a part and does a tick and a sign somewhere, but we are basically really real-time seeing and codifying what people are seeing, and we trace that back into a supply chain. And I think don't underestimate the power of those big industrial users pushing those technologies through. And also when I look, for example, you mentioned China. China is a very, very interesting case for automation right now, because labor is just increasing a lot in China. And you see jobs, for example, end-of-line palletizing, that was done by guys, right? But they just don't cost $3 an hour, but now cost $9 an hour. That makes a difference. At the same time, this is not the most interesting job on earth to basically do palletizing all over. Also not so good for your spine and your back. So there I see a clear demand. And believe me, I think Chinese buyers are the buyers around the world you can find who are the most economical. You know, tell me exactly what will be the payback of that and of implementing that. So I think making realistic and proven business cases out of that, taking the 3 guys out, putting a palletizing system there, and the payback is something like 6 months. That's the type of work we need. Or we work on the system work, like bringing a supply chain standard similar like to electronic data interchange. I think automotive industry is leading there. That will help us push the transformation. And I'm with you, there will be people who will just say, leave me alone with that type of technology. I understand myself as a producer of good, whatever, hardware, and I don't want to do with the information systems here. Yes, and there will be leftovers, indeed. I also think so. Thank you. We had one more question here, yeah.
It seems like at least in the United States, robotics and industrial automation gets a lot of bad press. Read about horror stories in the news of robots going to take everybody's jobs away. Have you seen that at all? And especially when you go to implement robotics or industrial automation in a company that maybe hasn't had it before, have you had to deal with the current employees at the company, bad blood, or how do you work through that so you don't make everybody upset and quit?
Very good question, and yes, we see that. I mean, you can see that, right? When I talk about the job and end-of-line palletizing, 3 guys doing that, here comes the robot. I mean, people are not dumb. They see, okay, this guy's going to take over our job, pretty sure. So I think then what I noticed when working in a factory is often, indeed, what I mentioned in the beginning. If I define my work as I am the guy who palletizes, or I am the guy who moves stuff from A to B, and then indeed the robot or the automated logistics system, the AGV, is my enemy. And this is not a fair game, because the machine will win. But if I define my job as I'm logistics, I'm enabling plant operations, I am enabling, for example, I'm not a palletizing guy, but I'm working in commissioning. And commissioning, I commission products the way that they can be in a 7-Eleven, where we don't have much space and products need to be assembled right in the way they hit the shelf. Then this becomes more interesting. I think this is the very important step. Also a little bit of an educational and cultural step that when I said third learning, take people along, that you have to basically work with them to understand it's not my job of moving stuff from A to B and now the AGV does it, but my job is basically working for logistics for that plant. And if you succeed in basically getting that message across, then also you are away from that paradigm, me versus the machine. That's often the thing, and trade unions, I believe, they have gotten that. So I mean, there's no point of writing a story of robots killing our jobs and so on. If in the end it's really better and it's more economical, we don't hurt people's backs by implementing those robots, it's gonna come. By the way, anecdote was also when the automotive hit the world, people were very much upset because they said it's gonna kill the jobs of all the horse carriage riders, right? They will be gone. Reality was the automotive was one of the biggest job boosters we've ever seen on Earth. So that doesn't help when you tell it to the worker right now. It's a little bit of an analogy, but I think overcoming that problem of him taking over my job, but defining my job a little bit different, or working alongside with the robot as we've seen here, I think that's the way around that. I think we still have time for 1 or 2 questions before the show starts. Yeah.
Thanks for joining us this morning and spending your time with us. It seems that lots of technology vendors tend to be over-optimistic or over-promise in what they can deliver, and at the same time, customers are either equally over-optimistic or they're very conservative and skeptical about what can be accomplished. Have you got any guidelines or recommendations on how vendors and customers can converge on a realistic solution that would have a high probability of success?
I think that's a fantastic question, because indeed what I often see is the problem of fantastic technology, but if you don't know where to apply it and why to apply it, it stays a little bit like toys for boys. Right? It's cool tech out there, but what is really the pain point you're addressing? You know? But if you, in my example of equipping the packaging machine with sensing technology and basically not allowing that error of misfilling anymore between hazelnut and chocolate, I think there is a key. You need to understand what we call a pain point. What is a real pain point of such a food and beverage producer against his brand, his customers, but also against regulation and working against that. And at some point of time, yes, I worked around, or I talked a little bit around the notion if we connect that all and if we make that all possible in a continuous flow, that's beautiful, but at the same time, I would say stay with the say framed problems and the framed pain points. I mentioned the pain point of misfilling. I mentioned the pain point of collecting and measuring the weight of a container. That's a clear described pain point, and work from that rather than basically. And I know the brochures of the main automation providers of the world are full of that. And there is ProMat and Automate. Now there's going to be the Hanover Fair in 3 weeks' time. They're all going to push the whole new world. What's all going to be beautiful and everything will be connected, and there is enough IP addresses on this earth to connect every single piece of silicon we have on earth. That's okay, but the reality when wanting to implement that technology, I always see the thing, if you can attach it to a real problem, to a real pain point, and craft a solution where people see the value, and whether the value is taking 3 people out, putting a palletizing robot there, or the value is making that machine intelligent so it knows what it's filling right now. I think that's the essence, and then indeed work step by step towards a larger maybe also a larger vision of a system, that mess of a yogurt plant that won't look like this one in 10 years' time, I'm sure, but it will come step by step. It will not that you can just do it greenfield again. That's most often not the case in the US and Europe, that you have to do it brownfield, and you have to do it step by step, and you have to prove your value on each and every step. So if that's a recommendation, choose your battles, take a zone in which you can prove the value, and work step by step after that.
Thank you.
Yeah, there was one.
Thanks for your presentation. Can you talk a little bit more about your comments on truly connected enterprises, and when do you think that will take place, and what applications do you see that happening first, and what's the pushback? Is it around data security, or are there other factors as well?
Very good question on truly connected enterprises, so that basically throughout the supply chain and multi-tier supply chain, you could all see what's the ultimate demand, trace that down through the levels of the supply chain, working with production schedules and roll that over. Yes, that's indeed a nice picture to work at. At the same time, you mentioned it, there is a risk, and the risk is not only data security, what happens in the transfer, but it's also what is ultimately my reason being, my raison d'etre. When I'm fully transparent and everything that happens in my value add is controlled by my suppliers or by my customers, I can understand the pushback on that. So what I see more realistic right now is that the people are looking for exchange places and market places. The chemical industry has done something like Elemica, where basically they have created a marketplace for hazardous material. You know, that's a little bit more difficult with logistics, where they can basically put in their demand and forecast their demand, which is obviously as a value for producers. So I rather still, I'm thinking there on solutions that are controllable, rather than the fully cloud-based economy where everything is all the informations are in the cloud, and ultimately also that's a critical point of that. I think suppliers become interchangeable a lot. So I think we have to work around that concern a lot. And to me, it's an understandable concern. I mean, the guys from the Silicon Valley would always say, if the product that you've been given is free, chances are you are the product. because all the data that is consumed from that, and I think there is a little bit of truth in that, and I understand the resistance. So I also dare think working in rather controlled systems within an industry will be the next step. What comes after that? Maybe we open it up to the full-blown cloud, but I rather think it's going to work stepwise. Okay. One last question. Other than that, I would say no. Then I would say thank you for the attention this morning. I will leave you off to a great show, I believe. You'll see lots of that, and thanks again.